Hello everybody and welcome to our video on section 19b, which is about the area between curves. So in the previous videos, you watched me work through a slideshow where we were discussing where this idea comes from. This is just a summary, but essentially if y1, or sometimes we call it f of x, and y2, sometimes we call it g of x, are continuous on an interval between a and b, and y1 is greater than y2 for all x in that interval, that means that the equation, that the graph of y1 is always higher up than the graph of y2, then the area between those two curves is given by the integral between a and b of y1 minus y2 dx, or equivalently, the integral between a and b of f of x minus g of x dx. Okay, so think of it like there's a bunch of small rectangles that we're placing in this blue area that we want to find, and that the width of each rectangle is represented by dx. The height of each rectangle is represented by the difference between the top curve and the bottom curve. And the area of each rectangle then is y1 minus y2 times dx. If we try to make an infinite number of rectangles, a very, very small, have a very, very small dx, making many, many rectangles, then that should approximate the area of the curve nicely. Okay, that's essentially the idea. Okay, the summary from your textbook looks like this. It's on page 479, and your textbook uses the terms f of x and g of x. Again, it just says that the area between two curves is given by the integral between a and b of f of x minus g of x dx. Okay, and in this case, f of x is always the upper function, and g of x is always the lower function. Okay, so let's say I wanted to find the area of the region between x squared minus 2 and y equals negative x. It helps first to make a picture. So graph the region. We know how to graph x squared minus 2. That is a parabola, and its vertex is shifted down to 0, negative 2. And we know how to graph negative x. That is a line with a slope of negative 1. Now, if we want to find the area of the region between the two curves, they didn't tell me what interval I'm finding this area on. So I need to find the point of intersection of the two curves. Okay, so to find the point of intersection, I'm going to set curve 1 equal to curve 2, or in this case, curve 2 equal to curve 1. And I'm going to solve for x. In this case, I'm going to bring x over to the right-hand side. I'm going to factor, and I'm going to find two values for x. Either x is negative 2 or x is 1. Those are the two places where my curves intersect. Okay, so the points of intersection are negative 2, 2, and 1, negative 1. To find the area between the two curves, I want to find the area on the interval from a to b of f of x minus g of x dx. So the lower boundary is negative 2 and the upper boundary is 1. The upper curve in this case, I can only really tell if I make a graph. So the upper curve here is negative x, and the lower curve is x squared minus 2. If I integrate these, I'm going to get negative x squared over 2, and here I'm going to get x cubed over 3 and 2x, and this is I'm subtracting those. So I expand that here, and then I'm going to evaluate them when x equals 1 and when x equals negative 2, and I'm going to subtract those results, and I end up with 9 over 2 units squared.